Well, good morning, everybody. Happy Friday. This is Jeremiah, and we're going to get going on some grading. Hope you are ready for this. Got quite a group of people here, and this is being recorded as well. So, hello to you watching in the future. I just got a couple real quick housekeeping things here. There's a Q&A button at the bottom. Um, so, I actually recommend go ahead and click that now and kind of get it situated. That'll make it a little easier for you to type in your questions. But also note you'll be able to see the answers to questions that other people asked. So it's a really good companion while you're watching the webinar. And then if you didn't find it at the top of your screen, that little view options, that's how you can exit full screen mode. So I like to do that if I need to get to something else on my computer. But anyway, yeah, I'm sure we're going to have some really good questions. We got some really good content. So sit back and get ready. And let me get this handed over to Amanda. I think Amanda is still on mute there. Okay, there
There
we
we go.
go.
It's been a while. Thanks, Jer, and welcome everybody. As Jer mentioned, my name is Amanda Berry, and today's going to be fun, at least in my books, because quite honestly, I really love the grading aspect of landscape architecture. So we're going to get very technical with some grading terminology and practices, as you've probably, today, we're going to go very simple, but you can get very technical as you've seen in some of my past webinars. If you want to kind of go into Civil 3D or that, but today, very, very simple. So we're going to be covering some basic concepts in grading, and then we're going to apply them using some of the grading tools in Land Effects and SketchUp. So I'm going to kind of go through a few techniques. So we're going to learn the basics and then we're going to apply them. So it's a kind of a all through thing, and you can definitely follow along on this one, and you'll get something kind of tangible in the end. I will be going very quickly through it though, so just sit back and relax and watch it the first time through, and then kind of apply it on maybe an example project of your own later on. And I'll be giving some tips throughout. So let's start right off with the importance of why creating an accurate grading plan, why you should be doing that, and where things can definitely go wrong, and why it's important to know all the fundamentals. So we're going to be going through the fundamentals for people who might be a little bit rusty in terms of since the last time you tried to learn grading. So I've bulleted out here the reasons I was taught in my classes through the layer exams and through my own experiences as a landscape architect on the things especially to look out for when you're considering how you're going to grade a site. So for instance, right at the bottom, the loss of profits, mistakes in grading calculations, they can cost a lot if an extra needs to be applied for when the contractor discovers your mistake on the field. So that's why making sure that you're doing all of your spot elevations and slope callouts, all of that is very important to be accurate. For the drainage point in the middle there, poor drainage can also impact the longevity of your design, as can, so I've kind of, longevity really comes into play in a lot of these points for accessibility, for safety, for drainage. If any of these items aren't hit on appropriately when you're grading, then they'll have to be fixed later on, which can have a big impact on the design that you did. Like somebody later on could completely redo your design, which is absolutely not what you want to happen. So for instance, for poor drainage, since it could, if you have kind of pooling, it can undermine materials that shouldn't be in standing water for too long. Grass and plants can die in standing water, and retaining walls or garden walls could crack if there's too much water kind of standing in there. For safety, obviously, you want people to be able to go through the design I would like to add kind of to the title of this slide, not just an accurate grading plan, but also a well-communicated grading plan. Because if you go through the whole process, but you don't actually communicate crucial parts of your grading design, then those could be represented when it actually gets constructed, again, leading to extras. And as we'll get into, if you set up the communication right, you can actually get the added bonus of going to 3D easily and giving added value to your client. So that's what we're focusing on today. At the end of the day, we're going to kind of have that plan that we can take to 3D. But let's kind of learn some of the very basics of grading then. And if you want to kind of continue on this, these are some of the fantastic resources that I was referring to while creating this presentation. Kind of going back in time, I still have my site engineering for landscape architects from actually when I was in university. So I was definitely referring to that to kind of see how they broke down the basics. So I'm going to be going through it kind of quickly because we have an hour to get the highlights and kind of explain it how I like to think of it. But then I definitely recommend diving into it deeper afterwards. So the very first thing about grading, I kind of broke it down to grading is determining and communicating the slope equation across your entire site. So I'm simplifying this a lot, as you can see by this diagram. And like I said, I encourage you to learn this from multiple sources, but this is the equation you have to memorize, especially if you haven't done your layer exams for landscape architecture. You do have to memorize this equation for the grading layer exam, for instance. And also, if you haven't kind of gotten into grading for a while, I'll kind of touch on some key lingo that you have to know in terms of grading. So basically, you're trying to get from point A down to point B on the slope and determining what that angle is, and that is your slope. And slope is actually determined by the rise and the run. So slope here is rise over run. This is the equation that you're going to be doing. Slope can also be referred to as grade or pitch as well. And I've seen rise referred to as fall quite a bit in my daily terms. So that's kind of when I talk about grading, these are kind of a lot of the terms that I'm going to throw around. But I do know that a lot of these terms are location specific. So if you wanted to chime in at all in maybe the chat window, you can kind of chime in on other grading terms that I might have missed here, and we can kind of touch on that in the Q&A period. Or if you have questions about any of these slides, definitely use the Q&A box in the webinar. So if we kind of go into it though, there's a few variations of this slope equals rise over run that are also important to understand. And that's all of these. This is because in the course of grading, when we're grading out a design like a parking pad or a walkway over a hillside, anything like that, you are going to need to figure out any missing numbers in this entire situation. So that missing number might be you need to figure out the slope. Sometimes you need to figure out the run. Figuring out the run is actually going to be your second most used version of this equation. Or in some instances, you need to figure out what the rise is. Or actually, sorry, rise is probably, the rise and run, they go back and forth quite a bit. I won't dive too much into the math, but it does get easier to memorize these if you do take the time to learn how the equation actually flips around, especially if you're like me and you're diving back into grading after a little bit of a break and you haven't had this memorized anymore. I was easily able to kind of flip this equation around in order to show it to you. So that's an easy way to kind of memorize it, is by taking some time and understanding the math. And I've kind of added in here from my last slide. Here I just said slope equals rise over run. Here I've added that generally we like to represent slope as a percentage for the most part. And I just kind of added that times percent here because you will find that in a lot of equations that we do, when you add slope into the equation, it is actually a decimal, but if you want to represent the slope as a percent, it's actually times by 100%. And here is a very simple example to illustrate how we did this calculation. And I am kind of going through this a bit quickly, so you can go over this again. If you haven't in the recording, but if you haven't encountered this before, if you're still a little rusty from the last time you tried it, do take time to practice this slide. So things that I can recommend to start practicing and really getting into memorizing this equation would be to make 2 points on a piece of paper, just that simple, and pick a scale with a scale ruler, any scale. That's really good practice to kind of flip between scales. And then measure the distance between the 2 points and pick either a slope or a height. And then figure out the other one that's missing. So if you, you pick the 2 points, you measure the distance, and then you give it a height difference of 4. What is the slope between those 2 points? Or if you give it a slope like 40%, in this case, figuring out what that run is. Or you can basically do 1 dot on a piece of paper, choose the scale, slope and height, like 2% for 2 feet or 2 meters, and figure out the distance to the next point. You won't need to memorize all of this to get through this webinar though. That's really important, so you can still follow along. I am just illustrating the importance that having confidence in this equation will make everything that we go through later on easier, but it doesn't mean that you can't go through the rest of the webinar. So we have covered percent here, but you can also represent grade as ratio. So these are the 2 most common ways of representing this pitch or slope in a plan. So if this is a piece of pavement, if this is a driveway, if this is a slab of grass, these are the 2 different ways that you might represent communicating what steepness that is. So you can also technically represent this as a degree, but I will just say that's really seldom used for site grading. I personally have never had an occasion where I needed to represent my grade as a degree. It might be different in different scenarios, but it's just kind of my experience. You can take it or leave it. I have seen though, one thing I did want to mention, this ratio representation, the run to rise, which is that run to that rise. I have actually seen this represented as rise to run, so 1 to 5, most notably between the 2 books that I actually referenced at the beginning of this webinar. Both of those books showed ratio in 2 different ways. Personally, I learned run to rise, probably because it differentiates between slope ratio from scale ratio in metric Canada. So normally if I were to see 1 to 5, I would immediately think that was actually a scale. But I did kind of notice that a lot of places in Europe, for example, might do 1 to 5 instead. So that's basically the nuts and bolts then. Of determining and then communicating that slope equation, either as a percentage or a ratio. And this is how you're going to do it. We're going to find some easier ways though. That brings up a really big question. This is a land effects hosted webinar. And so what I want to do is be able to show you some tools that you can then use to help make this task easier on you and how I've made it easier on myself. I don't do all of my grading designs completely by hand anymore, although I may start them off that way. But basically the tools in land effects that we're going to go over are going to help automate that entire equation that we just learned in those last few slides. So that's why I'm saying you don't necessarily need to memorize it for this webinar. you can use the land effects tools to maybe get initial slopes, which I'm going to show you how to do, which can then help you make decisions yourself, either on paper. You can also automate the call out standards using the land effects tools for when you're actually communicating the construction plan for your grading plan. And we're going to basically cover all of these land effects tools that automate the equation for all the tedious parts of doing that calculation, so that we don't have to pull out a calculator for this webinar and I can actually fit it into 1 hour. It'll also, obviously, it's a tool. So we're talking about a tool just like a calculator. You need to know how to grade. And that's one thing that we're going to just kind of cover next, is some techniques in grading when using this tool. So the first thing I want to kind of note before we get into some of the ways that you can grade different areas would be some common percents and ratios that we just learned that you might use to grade those areas. And the biggest concern is basically the flow of water, and then also the safety of that area. So one particular note would be obviously a 0% slope won't drain. But you might have some areas like a pool or a playground edging that technically would be 0%. And that would obviously be in a scenario where you want the water to pool, or you were going to have subsurface drainage. So you're going to have a material that the water can sink through, but then you still have a grading and drainage system below that. And then as we kind of go further down, you'll see what percentages drain concrete, asphalt, grass. And then most notably, once we kind of get over 5%, we're really getting into a range where safety comes into play quite a bit, especially with accessibility standards in your local area. So for instance, between 5% and 12-to-1 is, and I'm flipping between percentage and ratios at this point, because again, how I was taught is that basically once you get into the higher percentages, usually a little bit about at that 8.33 and up, you start to express things as ratios. And actually over 20%, I almost always express them as ratios instead of percentage. Again, that's just how I like to communicate things and how all of my contractors were used to seeing all of that. And so notably with the ramp then, so between the way I was kind of, I learned in my area, a ramp is actually anywhere between 5 and 12-to-1. So that would be a ramp. And 12-to-1 would be the maximum that you were allowed to do it. However, there were accessibility standards in terms of if you did have a ramp, that you could only ramp for so long before you had to have a landing, and that landing needed to be a certain distance. So those are some definite considerations that we're going to cover today. And then once you kind of got over that, you were mostly going into grass and planting and all of that, as well as the notorious 3-to-1 max slope. But one thing I did want to note is that you do want to check out your own local area standards, because these do change. Again, between those two books that I mentioned at the beginning, actually the more European one, instead of 12-to-1, it was actually 8%, which was more of a 12.5-to-1. Was the maximum for a ramp. So don't take this for granted, this slide. Check out your local accessibility standards and your local bylaws, especially. So let's kind of go into some examples. So when you're going into grading, the way I kind of wanted to simplify it for today is that it's about moving people or water at the end of the day, those are your two main concerns. You can get very creative with it, and you can start using grading in terms of excitement or interest in your design. But your two main concerns are going to be people and water. So here we have a great example, just a soccer field. So this is flat, obviously it's not going to drain. You're gonna have water pooling. It's great for the players, but not great for water. So you have some options that you can start trying. You can do a pitch slope. So pitch is that word that we talked about at the beginning. And there's, once you do that, these are actually the most common ways. This side pitching, pitching over the width is the most common that I've seen in soccer fields, just from playing on them actually myself. But obviously it might be easy to figure out an advantage, go at the net from the top. It's going to be a bit easier to go at the net. Whereas especially this one is totally unfair. I mean, for soccer, you would kind of switch sides halfway. But one big problem that's going to happen here is that this one net at the bottom is going to get flooded quite frequently. So probably avoid that. Things to think about in this scenario. Obviously, different areas are going to be different. So here are some other terms and shapes that you can use in pretty much anywhere that you're grading. But in the case of the soccer field, that crowned is actually one of the best fields that I've played on. Pretty fair and minimal flooding at the nets or the goals, where the goalkeeper there'll be a lot of activity, a lot of standing. The grass can get really trampled. So if the less water draining there, the better. So that hipped crown, you probably have those issues around the goal where the water is flowing. And then obviously the hipped funnel, which you would probably use for more of a swale scenario, but I'm just showing it here, you're gonna have major problems in the middle of a soccer field. So that's not great. You're probably going to need to, if you are going to do this, maybe you're in a plaza instead of a soccer field, you're gonna need to start thinking about drainage in the middle there, so that you can get the water out that has to pool there. And then we have something you can always start combining them all and create that soft crown scenario. And this is kind of a summary of what we've just talked about. So you're going to be using all of these techniques while you're going to move the water while respecting the needs of the users of the site. So that could be people, that could also be cars if you're grading a parking lot. And one thing we didn't touch on, but we will touch on in our example, is that you need to respect the constraints of the site. So when we go through our example, you're going to start to try and find pinch points, because those are going to direct how you're going to use all of these techniques to grade around your site. And I'll talk about that. So key points is that the elevation at the property line is going to need to stay the same pretty much every scenario. You also can't change the flow of water off your property. So if water doesn't flow off in a certain area, you can't grade up and have the water flow off that way after you're done. If water already flows off in one direction, great, take advantage of that. So the pinch points we're going to talk about, and then like I did mention, look up your local bylaws. The last thing before we kind of go into, we'll kind of cover maybe one, maybe two questions before we kind of go into the CAD side, is you can't talk about grading without talking about contours. I'm going to talk more about, probably anybody who's done grading before might have looked into recognizing how to read contours. I'm going to touch on that a bit, but we're not going to do a full lesson on it. Just the very basics of contours is if you were to slice the land horizontally, that's where it intersects. So that green line in my example. And then interpolation is the word of the day, is choosing at which elevation you want to do that slice, and then determining where that green line will land based on what you have graded. And so here's the equation of how you would say find the run to determine where that green line is going to land in respect to, oops, go back up, this point right here. how far along horizontally is that green line going to land? Because again, we're drawing in plan view, even though I'm showing it in 3D right here. And I'll show you an easier way to do this than what I've shown on this slide, but this is the basics of what the easier way is doing. So let's see, are there any quick questions, Jeremiah, before we jump into CAD?
Just one quick comment to when we get to the end to remind everyone again of those book resources. But no other questions than that.
Perfect. Okay. Then with that, let's have a quick look of what we're going to do on the land effects side and in CAD. So here's our plan that we're going to be working with today. And the things that we want to think about while I'm going through all of this, and I'm going to show some techniques on how I think about these and go around the site, is first we need to think about the existing flow over the site. So I have some contours kind of laid out, and you can see the elevations. I always label the elevations on the high side of the contour, not the low side. So you can see it goes down 121, 120. So the 120 is going to be closer to the 121 than the 119. That's very basic of drawing and communicating contours. We want to definitely drain away from buildings and pools, and your local bylaws are going to tell you at what percentage you need to do that for what distance, so you can kind of refer to those. But positive drainage away from buildings and especially pools, because you don't want leaves to flow into the pool. Think about your minimums and maximums for ramps and that 3-to-1 slope for grassy areas. We don't want to create any pooling situations against any of these garden walls. We have a lot of walls going in here in our design. We also want to think about, there's a lot of this walkways and the driveway. Are we going to cross slope these? So have the water sheet flow across. Sheet flow is basically another term for that pitched slope. And then, or do we want it to crown so that it starts in the middle, just like I showed in that soccer field, and it drains either way. And if we are doing crowns or sheet flows, we need to think about if we need any swales, if we're going to need any catch basins or drains in any locations, like I talked about in that one soccer example with the reversed hipped area. And then keeping in mind, we don't want to change the property line and we want to keep existing drainage. So I've kind of mocked up an example here of how I want this to happen. So really, I'm kind of looking at this in a general way. I'm not even getting into the exact slopes or anything. And I'm just figuring out how I want the water to flow around this site. And then I'll kind of work with that in how I want people to move around the site. So the blue arrows here, I've kind of outlined where the existing flow is. So really quickly, in a nutshell, water is going to flow perpendicular away from a contour line. So in this case, if it's flowing down away from a contour line, obviously water's not going to flow uphill. If I kind of flow it that way and I flow it this way, those start to point together. That indicates that this is more of a natural swale kind of feature. And unfortunately, that goes right into our building where we definitely do not want the water. So we need to divert that water somehow. I also don't want this water going straight in and pooling in my entry parking area. So what I'm going to do is I'm going to want to probably create a swale and divert it around my features and then have everything basically kind of drain down towards that swale. And that is going to be my game plan. Of course, you're going to want to eventually start thinking about things like limiting the impact of your grading and for if you have trees on the site, but we're going to keep this super simple. and think about just how we're going to grade this in general without thinking about trees or the limits of the grading right now. And then once at the end of the swale, this is more of a design consideration of how you want to end your swale. I'm probably just going to have it peter out and start filtering and draining naturally at the bottom of here. Okay, so, oh, and then our pinch points that we're gonna be looking at. Okay, so the big one is we have a finished floor elevation. Usually, sometimes you'll be given this, sometimes you're going to determine that. Right now, we're just gonna pretend that we've been given the finished floor elevation for whatever reason. So a big concern is going to be the access points. So over here at the patio and over here at the entrance. Another big pinch point is going to be how this this driveway meets up with the existing property line, because we don't want this driveway to be too steep for a car. Generally, I tend to keep those under 10% for driveways. And then again, the pool is going to be a big pinch point because that needs to be flat and it's obviously on a slope. And so we're going to figure out all of that out, how it's going to work with all of this. Okay, so let's go over to CAD. So here we are in CAD in this plan. So the very first thing that I'm going to introduce you to are our two main grading tools in land effects that I'm going to be using to basically take everything that we learned about spot elevations and slope and automate it for the purposes of this webinar, so that we can get this plan done pretty much in 20 to 25 minutes. So if I drop down, I'm in FX Site Ribbon. In your FX CAD or AutoCAD with land effects installed, you're going to have this FX Site ribbon. So I'm going to go over here to site callouts, and you're going to see spot elevation and slope callout right here. And these are the two things that I'm going to be using a lot today to illustrate how to do all of those equations. So the other thing that I want to make clear is that my intention is to eventually create a 3D SketchUp plan from this at the end of the day. So I'm going to go a little overboard on the spot elevations, a bit more than I might normally communicate with spot elevations. But I'm just going to do that for today so that you can see it and that I can get that 3D. And you can always do this and then maybe freeze these, freeze the ones you don't need later on. So if I click on that spot elevation, the very basics of this tool is I click on a point, it asks me to create an elevation and a style. I can choose a style. So I'm going to probably maybe do existing to start with to pick out some existing points and click OK, and then put in an elevation like 100.00. And we haven't talked too much about units, but we're not going to worry too much. I am drawing in meters here, but basically everything I'm going to be doing is exactly the same as if I was drawing in feet. So I just click 100 and I pop that in, and there. It's all in. I've already set a project and a scale for this land effects plan, but that's basically what it's creating. It's creating an M-liter spot elevation here, and it's creating a block reference right here. So those are that's the spot elevation tool. And then we have our slope call out, which I can then click down and pop it in and tell it a percentage or ratio. So I can tell it what it is. But I can use both of these tools. If I say this is maybe 10%, it'll communicate that. I can use both of these tools to also automate creating these. I don't have to type them in manually all the time. So I'm going to show you some techniques to use while you're grading to automate these things. So the first thing I'm probably going to do over here is I'm actually, since I've got to go to 3D, and I could create a 3D plan off of these contours. I happen to have contours that are at elevation, which is really, really handy. If you have contours but they're not at elevation, I do recommend that you click on them, open up your properties, and edit that elevation to be accurate to what that elevation actually is, because it will help you with this point. So in my 3D, I'm going to want to basically grade all the way up to the property line. I'm going to want to show that. So what I'm going to do, and this is also going to help me out with calculating some other things, I'm going to do a spot elevation. And here's a key thing about spot elevation. If you I have a parent intersection on in my object snap settings. If you click on a line, polyline, that has an elevation assigned to it and you snap to that, spot elevation will actually automatically fill in that first point with that elevation. I'm probably going to freeze these existing elevations later on, but I just need them for that 3D and for figuring out some things. But I can basically kind of go along and start putting in all of these spot elevations along here. So I'm gonna click, 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 and go along. And I'm basically just gonna kind of do this side for right now for time's sake, but you can see how fast this is going. I'm just clicking 22, 122, and then I don't have a contour crossing through here, but I have one over here. So I can kind of put that in. So you would probably go all the way around. I would go all the way around and kind of figure out, kind of get that communicated. Oops, sorry, a little bit over scrolled. Communicated in here is just so that basically what I'm trying to do is get these blocks in here, because I can actually grab those. If you saw my power tip from about 2 weeks ago, you can grab those blocks and bring them over to SketchUp. However, you probably will get to a point like this where I don't have a contour going through to very clearly tell me what point this is. I could guess, but that wouldn't be very accurate, which can cause problems with your grading. You want to be accurate. So this is where the interpolation comes in. So with the interpolation, if I wanted to calculate this point right here, I would figure out, first of all, I'd figure out the slope between this point and this point. So a straight line through here. I'd figure out the slope between those two, and then I'd figure out the run over here in order to determine, switch the calculation over again and to determine the drop between the 123 elevation I know here and this point right here. So I know the distance between these 2 points, and I just need to figure out the slope in order to figure out the drop or the fall or the rise. So what I'm going to do is I'm going to grab, I drew a line through here already so that I could figure out where that intersects right here. So I'm going to go to my spot elevation tool, and I'm going to, I could pop this in, let's see, 123. I could pop this in and then determine that the slope between here is, I could calculate it all out with those, with that calculation we went over, or I can cheat a little. It's not cheating if it's automating. It's just kind of taking the right kind of shortcut to save yourself time. I'm just going to use slope callout. So slope callout can actually determine between 2 land effect spot elevations. So I just click this one, and I click this one, and it creates a slope callout. And I could delete that later. I can just use it right now for helping me interpolate this. So I see that the slope between these 2 points is 4.3. I can easily figure out, I could now determine the distance by doing a distance command and kind of pointing that spot and figuring out that it is 5.79 and timesing that by 0.043 for the slope to get a 2.5% drop. So that this would be 22.75. So I've kind of just told you the equation here. Or I could just go for a spot elevation. And this is using our slope callout and our spot elevation to help you automatically interpolate. So I can do relative to existing or continue from last, but I'm going to do relative to existing. So I'm typing R, enter, and I'm hitting 123. And I am going to manually put in that slope. that my slope callout automatically figured out. It is going down, of course, so I'm going to click down, and I'm just going to go slope follows a straight line. Click OK, pop it here, 122.75. So that's a way to interpolate a point that you don't know. So I can easily do that over here. So I can kind of figure out over here that this is, let's see, I'm going to I could determine basically across here and figure out this point. But for the sake of time, I am just actually going to tell you what this point is. Now that we've kind of learned how interpolation works, I'm just going to pop this in, and I know that it is 121.85. And I'm actually going to switch my callout style from existing, and I'm actually going to now make this a proposed, because it technically is calling out a proposed feature. So I'm going to switch that over to a proposed style, or I'm going to go with that style and say OK. And then just place that in 121.85. And I'm going to communicate that on both sides of my roadway, so it's very clear of what I'm going to do, because what I am going to kind of communicate along here is that I want to crown this roadway. And I want to crown it so that it drains positively, and we learned that for asphalt you can go between at anything over 1% will drain positively. So I'm just going to keep this this plan example simple, and we're just going to go 1%. So I can do that technique that I did for interpolation and just figure out what this is at 1% up. So I'm going to do another relative, grab that one. I'm going to change that percentage to 1%. I'm going to go up. I'm going to say OK. And that's the start of my crowning. So we've kind of determined a few points along here, as this is one of our pinch points that we identified before, but a lot of our other pinch points are closer to the building. So I'm actually going to start and change gears over to the building. If you didn't have a finished floor elevation, you might at this point start making some moves to determine going down this this driveway to determine what your finished floor elevation might be. But we're just gonna, since we got this, we're gonna start with this. So first of all, I'm gonna think for this hotel, I want this area to be flush entrance, but then this area kind of steps down a bit for that kind of grand entrance look. So I have a few variables that I already know based on this. So I can basically go in and grab my spot elevation, and I know that this is 2 risers here, and I like to call out 2 risers just like that. And to create this, I actually just went over to my text manager and picked my call out text, and then just did some text and typed 2R. So I like communicating stairs in this way. And so I'm going to go to my spot elevation. I'm going to, for metric in meters, stairs I typically do them at about 6 inches, or that would be 0.15 meters. So that's what I'm going to do. So this is 2 risers times 0.15 is 0.3. So this elevation is going to be 119.2. So I'm going to say OK. And we're going to pop that in. 119.2. And I'm just going to put that over here. Oops. 19.2. Or not 119.2. That's 119.35. Yeah, 119.2. I am going to put that in here. And if you ever get this, I kind of mistype that, you can always go in and double click this spot elevation and just type in that extra bit that I forgot to type. Generally, I communicate my spot elevations to 2 decimal places in meters, also in feet, I do that as well. And so I've kind of determined those main spots. Over here, I'm actually going to keep that flush, so I'm going to do a spot elevation over here of 119.5. And this is a design consideration. I probably do this especially in a hotel situation like this, since probably people staying there might be a little bit, have some mobility issues. They want to be comfortable in general, or I just like that kind of look of it being that flush. So it's almost like an inviting room off the back. But then what I want to do is, so this is actually pretty significantly lower than this side. And I have a walkway that's going all the way around here, and I need to drain positively all the way around the building. So there is probably going to be some foundation exposed over here. But generally what I'm going to want to do is start gradually grading down to over here. So what I'm actually going to do is, this is a porch with an egress over here. So I'm just going to have that egress be one step and this kind of grade down to here. So that's going to be 0.15 or 6 inches. So I'm just going to go in here and do a 119.35 to indicate that this is going to be a step down. And you can also at this point, if you wanted to, start taking advantage of the additional points in the spot elevation. So you might say like a top of step, so TS or TW for top of wall maybe in this case, and kind of differentiate between the two if you like, and put in that 0.2 with abbreviations. I'm just going to go pretty simple in this case, 19.35. And I'm going to copy that because I'm going to put that in a few different spots. So 119.35, 119.35. And there we go. So we've basically kind of established some of our known grades in here, and now we're going to try and grade between all of them. And as we go through there, we might determine some pinch points that we didn't previously think about. So in this case, what I'm going to do is do a lot of that relative. So I'm going to grab here, I'm going to do 1% and down, and I'm basically going to go down like that, and I'm probably going to keep this flat. So I'm going to do 119.12 over here, and these are all M liters. So after you place them, you can move them around to make things more clear. And then probably I'm just going to go with a one. Based on our plan, I'm trying to sheet flow around this fountain. And basically down to my swales over here. So I'm going to do another relative, 119, and basically kind of go down there. And I'm going to keep going down 1% or 1.5%. I probably should have done that one at 1.5%, and kind of go down until I get to this point. And let's just kind of skip ahead a bit and pretend that I did a 1.5% down from here, because basically I want this all to sheet flow down to here. So that's going to be my spot elevation right here. And then I can do a relative, grab that, go 1% up to get my crown at this point. And then it's basically kind of what I was doing before. I can grab that slope call out, grab this spot, and figure out that that's 6.9 and start filling in this crown through here. And I probably want spots here, 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 and here. And basically what that's going to bring me to is now being able to figure out how to grade my swales. So I'm going to kind of skip ahead to that point for the sake of a little bit of time. And you can see how I've kind of gone through here and illustrated some of my grading throughout here. And I've gone ahead and done one swale all the way down. But my key point is that I want it to basically land pretty close to the even grade, the existing grade over here. So what I would do in this case is try and figure out where my pinch point is. So in this case, I want this swale to be at least 2% because it's on grass, so it drains positively. And I figured out one pinch point right here that for a 2% minimum, it needs to be at that point. So what I can actually do is I figured out at a 2% minimum, this point needs to be this. So now we just need to figure out what this is going to be. So I could figure it out by doing, if I do a spot elevation, and then kind of grab that one and do a relative, and do a 2% up and follow a straight line with, you can do spot elevations every certain amount of distance if you want, but I'm just going to do a straight line right now and say, okay. I can determine that that is going to put that at 120.72. But even right now, I can figure out that that's going to be a massive 1 meter or 3 foot drop, over 3 foot drop from these 2 points that are very close together. So that's not a limiting factor. This is looking like a limiting factor. So I'll probably want to figure out at this point, I'm just going to delete those, or you can do an undo to just quickly undo them. I'd figure out what this is by 2% and make sure that this will positively drain. So if I do that and do a relative and go down, that gets us to 121.71, and that is actually pretty good here, and I can double check it if I want with the slope to make sure that that conforms to my 3:1 standard. But I'm just going to go with it and then be able to quickly tell what the slope is between those. I can start using that slope call out to be able to confirm my grading design, that it fits within what I need it to do. And then once you basically get to that pinch point and you've pretty much figured out what you want for the rest of this, you can use that spot elevation tool to basically do a relative to existing, grab this one and go, I determined it was pretty much like I believe a 3% down, and I can follow that polyline and place spot elevations maybe every 15 meters of horizontal distance. And I can just kind of click on this and it will go to town. And that puts me at 16.1. I probably actually needed to do that at about 4%. So I can just do an undo, escape, undo, get rid of all of that. Oh, undo, end, and then another undo. There we go, get rid of all of that and just regrade that at maybe 4%. And kind of use all of that information. But as we go along, what we're going to do, especially since we're kind of running a little bit, I spent a little bit more time than I thought I would based on my initial plans. But basically what we're going to end up doing is kind of going around and using all of those techniques that we just learned with all of the criteria that we learned during the slides to start grading the rest of this. So basically, I'll just show you what I did. I went 1% to determine that. And then I basically followed this along and knew that I needed a 12:1 ratio. And like you saw before, you can do grade down by percent or grade down by ratio. But what I also know is that I can only go for 9 meters, which is about 27 feet, maybe 30 feet, before I needed a ramp of about 1.2 meters or 4 feet at a certain percentage. So I went for 9 meters and then did 1.2 feet at 2% down, and then 12:1. I wanted this to be relatively flat to correspond with the seating area and pavilion. And then I went down, and that basically created a pinch point around here of how quickly I could grade down this ramp to get to this pool, because I didn't want to have this pool too far off of existing grade. So I basically followed that around and was able to grade up at 1% to make sure everything was flowing around the pool, and made every point in my pool the same elevation, and then just made sure I was grading away from it. At this point, though, I determined that I did have a little bit of an issue with grading away and this area, because this was higher than this. I basically at this point started determining where I might have pooling and decided I didn't kind of go into this, but something to consider when you're grading something like this. I decided the best solution in this case, and there's always multiple solutions to a problem, would probably be to have a little bit of a swale in here and then a drainage kind of trench just through here with maybe a grate over top so that it could just kind of flow out here. I decided that would probably be the cheapest and most economical option instead of having it drain in here and put like a little capture drain or catch basin even and pipe it out there. I decided a little channel drain was probably all that this needed to be able to drain these two areas out, and the rest of it could sheet drain. A big consideration when sheet draining is that you don't want large areas to sheet drain over a pathway. Generally, I learned that mostly because water freezes up in Canada, but I think it's a good consideration in all climates because that could easily lead to a lot of debris and soil kind of sheet flowing. So if you just have a little area like this, sheet flow across a walkway is absolutely fine, I find. But if you're getting a lot of drainage, you want to start considering swales on the one side of a pathway in order to limit the amount of water that would sheet flow across it. So those are some just design considerations. And once you've got all this together, really easily, what you can do is I just started using that existing spot elevation to start creating spots at a relative extent of grading to make sure that everything was kind of conformed with the existing grading for popping it over to 3D. And once I got all of that, you can basically, with this kind of a plan, just grab that existing spot elevation block and grab this proposed spot elevation block. And I right click and do select similar to grab them all. And I basically just did a W block. So W block, if you haven't seen my power tip, this would be new to you. If you have seen my power tip, this is another way to do this. I wanted the exact same base point, 0, 0. I'm going to retain these objects and I'm just going to make that new block and say OK. And that would basically save just those blocks out. Oh, and before I did all of that, I actually ran the fx_spot elevation z align, and that will pop all of these elevation blocks up to z elevation. So that you get all of these blocks that were previously at 0 position Z or Z up to what the spot elevation actually says they are. And then you kind of bring that over to SketchUp, and I could just do this in 2 minutes. I basically grab this, grab that CAD, working, grab those spots. We're going to grab the DWG, grab those spots, import them, close. And what you're going to do is I am going to actually at this point probably refer to that power tip. It's a short 3-minute video. You're going to be using if I go over to extensions, guide tools to create construction points. And then you're going to be using Topo Shaper to turn those construction points into topography. And at the end of the day, what you end up with is something like this that you can then import your SketchUp buildings. I imported my line work from through the 3D connection in Land Effects to bring in all of my walls and bring in my line work, and I also have some additional power tips that show how to create that line work and intersect that as well. I think that's probably a good point. Maybe we can, if we have any time, we can touch on some additional things. I can bring up that, I'll bring up that slide that I had before. 1 sec. oh, if you do need some help, we won't check your grading, but we will help you with the tools. But if we want to look at that one slide, let's see, where was that? Oh, yes, these other fantastic resources. So I see that we did have one question that kind of came in to explain how to determine the finished floor elevation. I basically just kind of arbitrarily chose it in order to, as an exercise in here. If I were to actually determine the finished floor elevation, I would want to figure out the limiting factor. So I might actually do this exercise of grading maybe a few times and backtrack a little bit and make changes actually. Probably after doing this plan, I kind of determined the main pinch point would be, was one, the pool, and two was this entrance over here, and that I actually had quite a bit of leeway on either side. So I would probably want to grade either of those myself in a way that would limit the cut and fill. I didn't get into cut and fill today. That is a bit more of a advanced grading option. But yeah, basically you want to keep most of the elements as close to the existing grade as possible. So I would basically choose the finished floor elevation by what kept everything else as close as possible to the existing grade. And sometimes that can take grading the whole plan and regrading it maybe 1 or 2 or 3 times.
And we did have a couple of other questions. It might be nice to hit on. Basically, if you could kind of point out the spot elevation Z-align, that definitely intersects with a lot of this.
Sure, yep, and so I kind of went through that, but let's grab this one where I know my spot elevations aren't Z-aligned. So when you first draw one of these spot elevations, oh, that one is Z-aligned. Let's go over here where I definitely didn't do it. Okay, so when you first draw one of these spot elevations, the position Z under properties is gonna come in at 0. So obviously if I were to export these over to SketchUp, they would come in at 0 elevation. But if I do the FX, and we'll go spot elevation Z align, there it is, or Z, yay Canadian. If I hit that, it will ask me if I want to set the spot elevation arrow, all of these spot points to a specified Z elevation, and I click yes. And basically what it just did was it took this block and it popped it up to the position Z that its associated call out is set to.
Correct. And then didn't you, we made a power tip video showing how to make then a surface from that in SketchUp
Yeah, you know
and
what?
Civil 3D. I couldn't remember if we did both of those.
Oh, I've done a few. So I did do, I really like doing this. And I like finding out those quick tricks in terms of doing that. So let me pull up, if you go to our website over here and then go to learn and then over to power tip videos. And I'm just gonna go to SketchUp for right now. This is the most recent one where I covered that entire process in more detail very quickly, actually. It's only 3 minutes long. And then I also did, if I wanted to do topo points in a tin surface from Civil 3D, but I also have some webinars where I've other webinars where I've kind of gone through some processes. Once you're in, once you are in SketchUp, we kind of go over how to import that line work. So in SketchUp, I basically went into my presentation tools under site and went to 3D connection and started sending layers like this paving layer. I just kind of sent that over and I was able to intersect that with the resulting. So I just kind of sent that over. And if we look at my 3D, you can kind of see below what I've done I've kind of intersected all of those together.
Very cool. So yeah, I think we got everybody covered, but obviously a huge desire for more functionality as we can approach grading and drainage and more contour tools. So definitely we see the interest here, and we will continue providing resources like these as well as functionality, like we've been adding to it. So do feel free to email us and let us know, what it is you're after, as we continue to pad out additional grading tools. But other than that, I'm going to wish everybody a happy weekend.
Great. Have a good day, everybody.